Imagine gazing up at the night sky, seeing countless stars, each a distant sun. Our current methods of space travel, like chemical rockets, make reaching even our nearest stellar neighbors an almost impossible journey, spanning tens of thousands of years. But what if there was a way to shortcut the cosmic distances, a scientific concept that sounds like something out of science fiction? Yes, the concept of local space distortion is indeed considered a key theoretical pathway for future interstellar flight. Scientists are actively exploring how manipulating the very fabric of spacetime could allow spacecraft to travel vast distances much faster than light, without actually breaking the universal speed limit. This idea stems from Albert Einstein's theory of general relativity, which teaches us that space and time are not separate, but are interwoven into a single entity called spacetime. Massive objects, like planets and stars, warp this fabric, creating gravity. Local space distortion for interstellar travel would mean creating a controlled warp around a spacecraft. Instead of the ship itself moving faster than light, the space in front of it would contract, and the space behind it would expand, effectively surfing on a wave of warped spacetime. Think of it like being on a moving walkway in an airport. You can walk at your normal speed on the walkway, but because the walkway itself is moving, you cover ground much faster than if you were walking on the stationary floor. In a warp drive, the spacecraft inside its warp bubble would not move faster than light relative to its immediate surroundings. However, the bubble itself, carrying the ship, could move across vast distances at an effective speed for exceeding light speed, relative to an outside observer. While purely theoretical for now, scientists are focused on understanding the immense energy requirements and the exotic matter needed to create such a warp bubble. Researchers at organizations like the National Aeronautics and Space Administration, or NASA, have explored theoretical models, particularly the Alcubierre drive concept, which describes how a warp bubble might work. The goal is to move from theoretical equations to designing experiments that could one day demonstrate even a tiny, controlled distortion of spacetime in a laboratory setting. One of the fascinating aspects of the Alcubierre drive is that it does not require an infinite amount of energy, unlike traditional approaches to faster-than-light travel. However, it still calls for negative mass or exotic matter with negative energy density. This negative energy is not something we currently have in abundance, or even know how to harness for such a purpose. Current theoretical proposals also suggest that forming and collapsing a warp bubble might generate intense radiation, posing a significant challenge for any passengers. Exploring local space distortion isn't just about reaching distant planets. It pushes the boundaries of our understanding of physics and engineering. It forces us to reconsider what is possible, inspiring new research into the fundamental nature of spacetime and energy. Even if a full-fledged warp drive remains a distant dream, these theoretical explorations are invaluable in driving scientific innovation and expanding humanity's cosmic horizons.